Welcome to Combustible Dust Safety Training. In this course, you'll learn how combustible dust forms, why it creates serious fire and explosion hazards, and what steps you can take to prevent incidents in your workplace. The goal of this training is to build awareness around the risks associated with combustible dust. You'll learn why dust accumulation can be dangerous, how regulatory attention around this hazard has evolved, and what practical work practices can reduce the likelihood of fires or explosions. By the end, you should have a clear understanding of how to recognize and control these risks. Combustible dust incidents are not rare or isolated events. They've occurred across multiple industries over several decades. From grain elevator explosions in the 1970s to fires and explosions in foundries, pharmaceutical plants, and insulation facilities, these incidents have resulted in significant loss of life and property damage. These examples highlight how widespread and serious this hazard can be when not properly controlled. In recent years, combustible dust explosions have drawn increased attention from regulators and industry leaders, especially after major incidents like the 2008 sugar refinery explosion. While OSHA does not yet have a single comprehensive standard specific to combustible dust, employers are still responsible under the General Duty Clause to maintain a workplace free from recognized hazards. Organizations like the Chemical Safety Board and NFPA have continued to push for stronger, more defined standards to address this risk. The National Fire Protection Association, or NFPA, plays a key role in providing guidance on combustible dust hazards. While NFPA standards are not OSHA regulations, they offer widely accepted best practices for preventing fires and explosions. Several specific standards apply to different industries, including agriculture, metal processing, manufacturing, sulfur handling, and woodworking. These standards provide a framework for designing safer processes and facilities. A 1999 incident at a foundry in Massachusetts demonstrates how quickly a combustible dust hazard can escalate. A fire started in equipment and spread into ventilation ducts where dust had accumulated. This led to a primary explosion, which then triggered a much larger secondary explosion when additional dust was dispersed into the air. The blast caused severe structural damage, highlighting how dangerous accumulated dust can become when disturbed. In 2003, an aluminum dust explosion at a manufacturing plant in Indiana caused serious injuries and a fatality. The explosion was fueled by accumulated dust inside a piping system. Investigators found that poor hazard assessment and lack of communication about the risks played a major role. This case reinforces how critical it is to recognize dust hazards and ensure workers understand the dangers. Multiple combustible dust incidents across different industries, ranging from coal and nylon to rubber dust, have exposed gaps in regulatory coverage. Studies from organizations like NFPA and the Chemical Safety Board have emphasized the need for a comprehensive national standard. These reports identified key areas for improvement, including hazard assessments, engineering controls, housekeeping practices, and worker training. The 2008 explosion at the Imperial Sugar Refinery in Georgia became a turning point in combustible dust awareness. Massive dust accumulation throughout the facility created conditions for a devastating explosion and fire, resulting in dozens of casualties. This event accelerated regulatory focus and highlighted how quickly combustible dust can become catastrophic when allowed to build up unchecked. Following the Imperial Sugar incident, the Chemical Safety Board issued several key recommendations. These included aligning facility design and operations with NFPA standards, conducting comprehensive safety reviews across all facilities, implementing strong housekeeping programs to control dust accumulation, improving employee training, and installing emergency alert systems. These actions are all aimed at preventing similar incidents in the future. Combustible dust includes fine particles like flour, wood dust, or coal that can ignite when suspended in air. When these particles become airborne in a confined space and encounter an ignition source, an explosion can occur. What makes this hazard especially dangerous is the potential for secondary explosions. An initial blast can disturb dust that has settled on surfaces, creating a larger dust cloud that fuels an even more powerful explosion. Even small amounts of accumulated dust, spread across a relatively small area, can create serious risk. A dust explosion requires 5 elements, often referred to as the dust explosion pentagon. The first three, fuel, oxygen, and an ignition source, are enough to start a fire. For an explosion to occur, two additional conditions must be present. The dust must be dispersed in the air at the right concentration, and it must be confined. If any one of these elements is removed, an explosion cannot happen. That's why prevention efforts focus on controlling dust accumulation, eliminating ignition sources, and designing facilities to limit dispersion and confinement. In 2003, a devastating explosion occurred at a pharmaceutical manufacturing facility in North Carolina. The process used fine polyethylene powder, which became airborne and accumulated in hidden spaces above a suspended ceiling. Over time, this dust built up unnoticed and eventually fueled a powerful secondary explosion. This incident highlights how dust can migrate beyond visible work areas and accumulate in places that are easy to overlook. Despite clean production areas, the facility had a critical blind spot: hidden dust accumulation. Many employees were unaware of the buildup, and safety data sheets failed to clearly communicate the explosion risk. Even those who recognized the presence of dust had not received proper training on its hazards. This case demonstrates how gaps in communication, training, and hazard awareness can allow serious risks to go unaddressed. Another tragic incident occurred in 2003 at a manufacturing plant in Kentucky that produced fiberglass insulation. Resin dust accumulated in a production area and was likely ignited by flames from malfunctioning equipment. The resulting explosion and fire caused multiple fatalities and extensive damage. This example shows how equipment failures combined with dust accumulation can quickly escalate into a catastrophic event. Investigators identified several contributing factors in this incident. These included equipment malfunctions, lack of fire barriers, poor communication of hazards, and ineffective dust control practices. In addition, cleaning methods such as compressed air and sweeping actually spread dust into the air, increasing the explosion risk. The absence of clear hazard warnings and inadequate inspection practices further compounded the problem. Preventing combustible dust incidents starts with simple but consistent safety practices. Regular housekeeping is critical. Dust should be removed using proper vacuum systems rather than methods that disperse particles into the air. Ignition sources, such as heat or open flames, should be eliminated whenever possible. Proper ventilation is also essential to prevent dust from becoming airborne and forming hazardous concentrations. These basic controls can significantly reduce risk when applied consistently. In many dust-related incidents, the most severe injuries occur not from the explosion itself, but from the resulting fire. Flame-resistant clothing provides an important layer of protection. This type of clothing is designed not to ignite easily, melt, or allow flames to spread across its surface. It also helps insulate the wearer from extreme heat. While it doesn't eliminate risk entirely, it greatly increases the chances of avoiding serious injury. Facilities that handle combustible dust must carefully evaluate electrical systems. Certain areas may require specialized equipment designed for hazardous environments. OSHA provides general requirements for electrical safety, while detailed guidance is found in the National Electrical Code and NFPA standards. Proper classification ensures that electrical systems do not become ignition sources in areas where dust may be present. Combustible dust hazards are categorized under Class II electrical classifications. These are further divided into groups based on the type of dust, such as metal dust, carbon-based dust, or other materials. Each type has unique properties. For example, some dusts can conduct electricity and create short circuits or sparks. Understanding these classifications helps ensure that the right equipment and controls are used in hazardous areas. Effective dust control is one of the most important aspects of prevention. NFPA guidelines recommend minimizing dust escape from equipment, using proper collection systems, and designing surfaces that are easy to clean. Hidden areas must be accessible for inspection, and facilities should implement formal programs for dust monitoring, cleaning, and maintenance. These programs should be documented and consistently followed. Controlling ignition sources is just as important as controlling dust. This includes using appropriate electrical equipment, grounding systems to prevent static buildup, and restricting open flames or smoking. Mechanical sparks and friction must also be managed, and systems should be in place to remove foreign materials that could ignite combustible dust. These controls reduce the likelihood that a dust cloud will encounter an ignition source. Employees play a critical role in preventing combustible dust incidents. Workers who understand the risks are more likely to recognize unsafe conditions and take action. Training should cover both specific job tasks and overall facility safety programs. It should be provided before work begins, refreshed regularly, and updated when processes change. Employers must also comply with hazard communication requirements, including labeling, safety data sheets, and proper training. Management teams are responsible for establishing and maintaining effective safety programs. This includes conducting facility assessments, identifying hazards, and implementing prevention strategies tailored to their operations. Supervisors must actively support dust control and ignition prevention efforts, encourage reporting of unsafe conditions, and ensure that corrective actions are taken promptly. NFPA recommendations combine both dust control and ignition prevention strategies. These include using proper equipment, controlling static electricity, maintaining clean work areas, and preventing dust from escaping into the environment. Facilities should also use approved vacuum systems, avoid generating dust clouds during cleaning, and implement structured inspection and housekeeping programs. These layered controls work together to reduce overall risk. Dust explosions can have devastating consequences, including structural damage, severe injuries, and loss of life. Workers may be exposed to intense heat, flying debris, and collapsing structures. These incidents often happen quickly and without warning, making prevention the most effective form of protection. One of the biggest challenges with combustible dust is that it is often underestimated. While past incidents led to targeted standards in specific industries, broader regulation is still evolving. OSHA has been working toward a more comprehensive standard, but in the meantime, organizations must rely on existing guidance and best practices to manage risk.